Welcome back to round 3 of me working through the challenges in my book, The C# Player's Guide. Same caveats as before. I'm not doing a whole lot of editing here because I need to make it something that I can actually work through, and because I want you guys to see the journey, not just the finished product. So we're getting to harder and harder challenges. There's more to kind of sort through and more ways that you might do it differently, and that's okay if yours is different. This is a way to do it. I won't even promise that these are necessarily even close to the official solutions online, but yeah, so let's just dive in. We are down to the Dominion of Kings. We are also sitting at, for the sake of setting the table here, we are also, we've got enough XP to be to right here. We have 400 more XP to get to level 4, and I'm pretty sure we're going to be able to do that in this video. We'll go for about 30 minutes, and then we'll stop and pick it up another time. So let's jump over to the Dominion of Kings. 3 kings, Melek, Kasek, and Balak, are sitting around a table debating who has the greatest kingdom among them. Each king rules an assortment of provinces, duchies, and estates. Collectively, they agree to a point system that helps them judge whose kingdom is greatest. Every estate's worth 1 point, every duchy is worth 3 points, and every province is worth 6. They just need a program that will allow them to enter their current holdings and compute a point total. I'm going to do something a little different than what I've done in the other challenges. I'm going to come in here and I'm going to put some comments so that I make sure to not forget any of this stuff. I'm going to put in a little checklist here. Create a program that allows a user to enter how many provinces, duchies, and estates they have. Add up the user's total score, 1 point per estate, 3 per duchy, and 6 per province. And then the last one on here is display the point total to the user. All right. So we're going to get input from the user times 3. We've done this before in a lot of the other challenges and in the book a bunch of times. I'm just going to start with int. We've got to do console.writeLine at, tell the user what we're looking for. And here we're looking for how many estates do you have? And then I'm gonna do this all in one step. So int state count, seems like a good name to me, equals console dot, sorry, not console, we want to do convert to int32 and do console dot read line. So we will, this kind of works from the inside out. We get the input, because we can't evaluate console convert.to int32 until we evaluate the parameters to give to it. So this will happen first, then this. In other challenges, we sometimes put those on 2 different lines, but either way would work. So console.readLine, so we'll get a line of text from that, and because it's a string, not an int, which is what we need, we'll do the convert. And then we're going to just do this for provinces. Well, how many duchies do you have? Sorry, duchies and then provinces. Duchy count. How many provinces do you have? Okay, so create a program that allows the user to enter how many provinces, duchies, and estates they have. Now, I guess I went smaller point value to bigger point value. This comment says bigger to small. The order doesn't matter if I did province first, but I think we can check that one off. Add up the user's total score, giving 1 point per estate, 3 per duchy, and 6 per province. So there's a couple of ways we could do this. I'm going to do it kind of the more spread out way first and then condense it a little bit. So int, like we could do like estate points equals the number 1 point per estate. So 1 times estate count. This is multiplying by 1. I could leave it out. I'm going to leave it in there for a moment because I kind of like the symmetry that we'll have with this next one. Int duchy points equals 3 times, not estate, duchy count. And the other thing I'm going to do here is I'm going to put a space in here so that the equal signs line up. And come on, Visual Studio, quit fighting me. There. An extra, so that things just line up better. To me, that's more readable. So I'm going to go with that. Int province points equals not 1 times 6 times. That tool in Visual Studio has gotten better and better and better. Now, in order to keep things lined up, I better come back here and add a couple more spaces. So there. So I like the symmetry, but like I said, this is not strictly necessary, but I like the symmetry that it has. Now we need to total it up. So int total equals, and we just add up all these numbers. Estate, let's make sure we get the points, not the count, plus duchy points. And like I said, this tool has gotten a whole lot better. The fact that it's even suggesting that now is really nice. That's what I want. Okay. Add up the user's total score, giving 1 point per estate, 3 per duchy, and 6 per province. We've got that total. And the last thing, so we can check that one off too. Display the point total to the user. This is a pretty simple console.writeLine. Right line total. Well, we could, that's technically sufficient. We just display the total. But let's be a little fancier here. Let's say you have a total of total points. Missing a plus. All right, so that should run. Let's check it. Let's think this through. Let's suppose I have I want to test this with some actual numbers. And we can do the easy case first. How many estates do you have? Let's do 0 of everything because that's easy. That point total should be 0. 0, 0, 0. You have a total of 0 points. All right. Do over. How many estates do you have? We have 1 estate and 0 of the others, and we should have 1 point from that. 1 point. And now let's do 1 duchy. So 0 estates, 1 duchy, 0 provinces. This should be 3. Good. And we'll do 0, 0, and 1 of these. This should give us 6. And it did. Okay, we're doing good. Let's do one more. It's a little more complicated. Let's do 2 of everything, which should give us, let's see, 6 times 2 is 12, plus 3 times 2, which is 6, so that's 18, plus 2 more for estates. If we do 2 of everything, I think our total should be 20. That's what it gave us. Okay, so let's see if there's anything we want to do here to rearrange this code. One thing we could do, we've made all these variables here, and like I said, this is actually, I think, a fine way to do it. This code, in my mind, is very readable. It makes it very easy to see, like what are we doing, what are we computing. I have seen people, when people post their solutions, I've seen people do something like this and say int estate point value equals 1, int duchy point value equals 3, int province point value equals 4. Obviously, as great as it is, it still needs some work. I'm not sure how it could possibly infer that, and I did 1 then 3. I don't know why it said 4. It could have said 5 because 1, 3, 5. It might have. I don't know. Anyway, enough about that feature. So I could do that, and now I could come in here and say province point value times the number of provinces, duchy point value times the duchy count, estate point value times the estate count. And if I'm going to do that, I might want to do that as well. Again, keep that sort of like vertical alignment going on. The one thing I do like about this is before, the 1 and the 3 and the 6 come out of nowhere, and it's not obvious why we're using 1 or 3 or 6. They're just numbers that are in there. And I suppose if this comment, by the way, I should be able to check that off. Anyway, with this comment hanging around, it may be pretty easy to say, well, I mean 1, 3, 6, and that's the pattern, 1, 3, 6. So perhaps just having the comment in there goes a long way and solves that problem. But Yeah, I mean, like I said, there's something nice about just putting this in variable names, and now I have a thing, and the number gets a label assigned to it instead of just having to like guess where the 6 came from. So definitely the comment or the variable name is definitely a plus. It added quite a bit more code here for whatever that's worth, and like I said, I think it might be overall, it might be well worth it. So I see a lot of people do that, and I think that's actually a pretty good idea. I don't think my solution had that. Maybe it should. Now, in terms of adding this total, like I could squish all this into one thing and do one. Well, I could do 1 times estate count plus 3 times the duchy. Really, what I want to do is just replace where I'm using the variable down here with the expression that we used here. And I see people often put parentheses around these. That isn't strictly necessary because multiplication happens first. So the 1 times estate count will happen. The 3 times duchy count will happen. The 6 times province count will happen, and they all get added together. So I believe you'll get the exact same results if you do it without the parentheses. Let's test that assumption. 2, 2, 2. Still gave us 20. But at the same time, like it like this starts to get hard to process. And by the way, if we want to get really crazy, we could squish that in here. Now we're going to have to. Now we do need parentheses around the whole thing, or it'll do you have a total of, and then take this 1, turn it to a string, and put it on there. And then it won't know what to do. A string multiplied by a number. So we do need the parentheses there. Now I don't even need this. But that's a very dense line. So I don't know. I kind of like this version. I kind of like this version here, even though the parentheses are extraneous. Like the compiler is not going to add in extra statements just because there's parentheses there. It knows it doesn't need them in this case. And what I like about this is it gives me these little, like, I can visually see these little bundles of here's a computation, here's a computation. But the other version with the variables is fine too, as well as the version that you give names to these numbers. They are all good. All right, I think that completes that challenge. So let's claim our 100 experience points from that, and let's move on. So the next one, the Defense of Consolas, 200 points. This is the single biggest one that we've had. The uncoded ones began an assault on the city of Consolas. The situation is dire. From a moving airship called the Manticore, massive fireballs capable of destroying city blocks are being catapulted into the city. The city's arranged in blocks numbered like a chessboard. The city's only defense is a movable magical barrier operated by a squad of 4 that can protect a single city block by putting themselves in each of the target's 4 adjacent blocks, as shown in the picture to the right. So, if this is where the target is, at row, let's see, these are rows. So at row 6 and column 5, we want to get all the coordinates immediately around it. For example, I just said, to protect the city block at row 6 and column 5, the crew deploys themselves to row 6, column 4. So that's the same row, but a different column. Here, same column, different row. Here, same row, different column in the opposite direction. And that, I think, needs a space. All right. The good news is if we can compute the deployment locations fast enough, the crew can be deployed around the target in time to prevent catastrophic damage to the city for as long as the siege lasts. The city of Consolas needs a programmer to tell the squad where to deploy, giving the anticipated target, something like this. So it gives us the actual program that we want to do. So I'm going to copy that and put it into our thing, and then I'll put the objectives in there as well. So I'm going to just keep hijacking this program. So this is the expected, how the program ought to run. So we'll make sure it ends up looking like this when we're done. This is one of those challenges I see a lot of people do really clever, creative things This version is like the most boring version of them all. Most people end up with either they copy this or they do something way cooler, and you should totally do the way cooler thing. All right, let's see. You know what? I might as well explain that while I'm here. There is, if you, what did I do? It's muscle memory, so I don't remember. All right, so I put the, that's doing some weird things. If I put the cursor somewhere and then I hold down, so if I hold down shift, then I can do selection, right? And I can push the up and down arrows and it'll get like additional lines. However, if I push alt and shift, so alt shift together and then push the down arrow, you see I get like an extra cursor. So now I'm editing the document in 3 different places, which means that I can backspace out all of these together and add in that. So I'm editing the document in 3 places. That's a super useful feature. All right, let's see. Ask the user for the target row and column. So again, we've done this a lot. And maybe I should have left some of that here, some of the code here before, so I don't have to write it out again. But row equals convert dot to 32. Okay. So we ask for the target row, and then we get it from them, convert it to an int. We ask for target column, we get it and convert it to an int. Now we've got a row and a column variable, and ask the user for the target row and column. So we are done with that step. Compute the neighboring rows and columns where to deploy the squad. Now, don't overthink this. We don't need a complicated grid to figure this out. We just, it's the coordinates like immediately left, right, up, down. Oh, you know what? Look at this. I've already got it wrong. I'm gonna, okay, hang on. I'm gonna make this match. And then I'm gonna change this from right line to right so that it doesn't wrap around to the next line, so that we'll get our input here on the same line. Okay, now, what was I saying? Don't overthink this. Like, it doesn't need to be a fancy grid. We just need the number to the left, the number to the right, the number up, and the number down. So this doesn't have to be too difficult. We don't need some complicated data structure to represent all these things. We will for challenges in the future, but right now this is just a simple. What we need is the column to the left and right, and the row above and below. So we can get this next. We can get this next line here. All right, let's see. So we could make something like 2 variables for each of the 4 coordinates. And make variables and store all these in here. So something like, so coordinate 1 is the same row and 1 less column. So equals row. So we could do something like this. Coordinate 1 column. And here we wanted to subtract 1. So column minus 1. And then we could do the same thing for 2. And maybe we can do that. The order doesn't really matter here. However, maybe we'll try and make this right. So see, this is the row less, and then here this is the column less, which we've got, and then it's the row minus 1. So basically all we have to do is reorder these. Make this 2 and this 3 to get it in that same order. And now we just display misspelled it. That means I misspelled a bunch of these because I copied and pasted. Coordinate. All right. I'm going to use my Control D shortcut to just duplicate these lines and just do 2, 3, 4. 4, 3, 2. It looks like I have now used all my variables, so we're probably good. I compute the neighboring rows and values. So we did complete that. Display the deployment instructions in a different color of your choosing. All right, we'll get to that in a second. So let's see, target row is 6, target column is 5, and that looks the same to me. So we're doing good. It doesn't actually, it says compute it. This actually doesn't say display it. I think that's assumed. Now, but before we go on to those other ones, let's a possibility here, kind of like what we were talking about in the last example. I could just skip going to a variable here. This could just be row, and then I could just delete this. And same here, this is column minus 1. So I could do column minus 1 and never hang on to the data in a variable, but just basically send it right through to output. If we were doing more than just displaying it, it makes sense to store this in a variable so we can use it later. Coordinate, so I can just take this, put it here, and coordinate 2 column was just the original column. Coordinate 3 row was just the row. And coordinate 3 column is column plus 1, and then coordinate, so this one is row plus 1. So all I'm doing is taking the expression that we used to compute that and just injecting it into these other expressions. And like I said, given that we don't do anything else with these variables, that makes sense. I get to just keep it simple. Now I can delete all that. I have a shorter program. Let's run this again though and make sure that we didn't break anything in the process. All right, what am I supposed to enter? Target row is 6, target column's 5. Yeah, that looks like it's still the same data. So let's see, display the deployment instructions in a different color of your choosing. So console.foreground color equals, well, let's see what our choices are. Console color dot there's not that many colors for console color. We could do, I don't know, let's do blue. Let's make sure that works. Deploy to, that blue is kind of hard to read. I'm going to change it. Cyan I know is brighter. All right, check that one off. Change the window title. Should probably do that here. Console dot title equals Defense of Consolas. Run that. And you can see that it changed the title. Now I think, well, let's, title still Defense of Consolas. I think it might change here. Yeah, so something is changing it back once the program ends. And if I wanted to, yeah, if we wanted it to still keep showing that through here, we could do something like console.readKey. Now it still says Defense of Consoles, but it's, the program's still running and it's still waiting for me to do something intelligent with it. So I push enter and now it stops anyway. So the title only stays that way through the duration of the program. But I mean, that makes sense. So let's see, what else do we need to do? Change the window title. So we've done that. Play a sound with console.beep when the results have been computed. All right, console.beep. We got, so I mean, obviously we could just leave it at that. We could just say console.beep. And I don't know if I'm recording sound from the computer itself, so I don't know if you're gonna be able to hear it, but let's see if it does it. It did. I want to try to use, so that, let's see, frequency. I think, yeah, I was going to say, I'm glad this brought that up. The call site is reachable on all platforms. Console.beep int is only supported on Windows. So this version where you can specify the pitch doesn't work on Linux or Mac or other platforms. So that's okay. The challenge doesn't demand anything fancy, but I'm just trying to do something fancy here. Like a descending, I think that was that the pitch or is that the time? Well, now I don't even know. Frequency, yeah, so that's the pitch and that's the duration. And again, I don't know that I'm recording sound from the computer itself. I don't know that you hear this. It does it, but there's a little gap between. Anyway, that's that, so we can check that off. Is there anything else that needs to be talked about here? I don't think there is. I think we've accomplished everything, but that was 200 experience points. All right, I think it's time to go on to the next one. So let's see, that was the Defense of Consolas for 200 experience points. Repairing the Clocktower is the next one. So the recent attacks damaged the Great Clocktower of Consolas. The citizens of Consolas repaired most of it except one piece that requires the steady hand of a programmer. It's the part that makes the clock tick and talk. Numbers flow into a clock to make it go, and if the number's even, the clock's pendulum should tick to the left. If the number is odd, the pendulum should talk to the right. Only a programmer can recreate this critical clock element to make it work again. Take a number as input from the console, display the word tick if the number's even, display the word talk if the number's odd. Hint, remember you can use a remainder operator to determine if the number is even or odd. I'm going to get some extra junk in here when I do this, but I'm going to copy these. Oops. Okay, so I don't like this. This is the first time we've used logic in our programs, but this shouldn't be too crazy, I think. So we'll do, so take a number as input from the console. So console Again, we've done this a lot. Dot read line console dot, sorry, convert. Kind of working the wrong direction here. Int number equals console dot read this is a hint. I'm going to remove that. So we only got 2 items to do on this. So this is pretty standard at this point. We've done this a lot. Just ask the user for a value, and then we get it, and then we convert it, and then we have it. So take a number as input, and display the word tick if the number is even, display the word talk if the number is odd. So the question is, how do we know if it's even or not? The way, like the way to do it, and the book does describe this, that hint called it out. If you say number mod 2, I say mod, but in the book talks about this, like mod and remainder are similar but different things. C#'s percent sign is a remainder operator, not a mod operator. For positive numbers, it's all the same. For negative numbers, they do come out different because mod should always be a positive number and remainder can be a negative value. But so the remainder after doing a division by 2. If no matter what the number is, this will be either 0 if it's a multiple of 2, or it will be 1 if it's not a multiple of 2, if it's 1 more than a multiple of 2. And those are the only actual numbers we can get for positive numbers. And this challenge actually doesn't specifically call that out. It maybe could, like, here I'm winging it here, but that's kind of the assumption. So this will either be a 0 or a 1, and 0 means it's a multiple of 2, 1 means it is not a multiple of 2, and that's equivalent of saying even and odd. So one thing we could do is we could say int remainder equals that, and then and then we could do something like if remainder equals 0, console.writeLine. Let's see. So display the word tick if the number's even. Tick. Else console.writeLine talk. I think that is enough to complete that challenge, but let's give it a run and see. So enter a number. Well, let's start with 0, which is an even number. Tick. Now let's do 1. Talk. Now let's do 2. Tick. So I think it looks like we've got it right. Let's for the sake of curiosity, let's do a negative number. If we do -1, talk. So that actually comes out correct. I think if I'm going to set a breakpoint in here and we're going to run this. If I do -1, the remainder is -1. So if this number is negative, then you're going to get negative remainders. Well, it might be 0. So in this case, since it's a negative number, we'll get 0 or -1. So -2 remainder 2 will give us 0. -3 would give us -3 remainder after a division by 2 would give us a -1 as well. But in this case, the way we've written this code, it actually works. If remainder equals 0, then write tick, otherwise write talk. I think if we had done it the other way around, we might need to handle that case of -1, or just ignore it, because that's not really the intent. But all right, so I think this works. I think a lot of C# programmers would likely just squish this all together. You know, a single expression And I think that works as well. Okay, let's see. So display the word tick and the numbers even, display the word talk and the numbers odd. So I think we've accomplished that as well. And let's do, I don't want to spend forever on this, but let's do one more of these. So let's see, we have gotten 3 challenges done. We're on this Watchtower. That actually is the 1, 2, 3, the 400 points we needed to get through. So we're level 4 now. We just got there. And now we're going to do repairing the Clocktower. Wait, no, we just did that. Watchtower. We're on this Watchtower one. There are watchtowers in the region around Consolas that can alert you when an enemy is spotted. With some help from you, they can tell you which direction the enemy is from the watchtower. And what it wants to do is it wants us to display text like the enemy is to the northwest, so you can see like depending on, so the watchtower is at 0, 0. And so depending on the coordinates they put in, we'll need different things. So we're going to use that image as a reference. I'm going to copy these over as well. I actually, like, this is I think a new feature of Visual Studio 2022 where it like wraps the line. I would rather have it just keep going off the screen, but I'm going to just handle that by, well, just wrapping it myself. All right, well, for the millionth time, we're going to ask the user for input. Int x equals okay, so pretty straightforward for that one. We just get a couple of values from the user, and we really rely on this user, don't we? Using the image on the right, if statements and relational operators display a message about what direction the enemy is coming from. For example, the enemy is to the northwest, or the enemy is here. So, I mean, there's 9. I'm going to bring this back really quick. There's 9 possibilities here. And all of them will depend on what the x coordinate is and what the y coordinate is. So I think this is basically going to turn into 9 like if else statements. And then just display different output based on that. So if x is greater than 0, well, let's start right in the middle. If x is 0 and y is 0, console.writeLine the enemy is here. And then if we go, like the north one is y is greater than 0, x is 0 and y is greater than 0. So this one is the enemy is to the north. And we can do same with south for y is less than 0. The enemy is to the south. And we can do west and east. And west is x is less than 0 and y equals 0. And east is x is greater than 0 and y equals 0. And now we need the 4 corners that are, I'm just going to copy and paste this. So let's see, northwest is y greater than 0 and x less than 0. X less than 0, y greater than 0. And northeast is x is greater than 0 and y is greater than 0 as well. And then the south, the enemy, so southwest is x less than 0, y less than 0. And then southeast is, maybe I'll just show this really quick so that, like I'm coming in here, I'm saying, well, I want southeast. So southeast is y is less than 0. Well, x is first. So x is, it doesn't have to be, we could have flipped the order on all of those, but southeast says x is greater than 0, y is less than 0. So then I just come in here and I say x is greater than 0, y is less than 0. And now I do southeast. So that's all this needs to be. Again, I see a lot of people do a lot of clever, fancy stuff with this challenge. Let's start simple. So if the x-coordinate is 0 and the y-coordinate is 0, this should give me the enemy is here. It's a good start. Let's try a couple more. What is the x-coordinate of the enemy? 200. What is the y-coordinate? -1. So let's see. So they are 200 units to the east and 1 unit to the south. So this should be southeast. Okay, that one checked out. One more. 0 and -20. So this is, they're directly in a line with us side to side, and the y-coordinate is down 20. So this should be just plain old south, I think. One of the things I see a lot of people do on this is like color, like especially this, like we should panic about that. Play a sound or change the text color or whatever. I've kept this pretty simple, and we can check that off now. But I think, for example, if you do want to do that, then a lot of these, then you need to put in the curly braces. And a lot of people just tend to do that, and I think that's just fine too. They prefer putting in curly braces. It does make for a longer program. But there's nothing wrong with that either. Long isn't necessarily a bad thing. It just depends on how readable it is. I have a preference for this, but I tend to prefer a bit more condensed. All right, that is the end of that, and I'm just going to check here. I think the next, yeah. So I kind of, the buying inventory and discounted inventory, like we're gonna pick up speed here as we move through some of these. So now I think it's a good time to stop, because these all start to some of these start to build on each other. So now's a good time to stop. So we'll wrap it up here. But let's see. So we did Defense of Consolas, and we dealt with some basic arithmetic, repairing the Clocktower. We finally got some logic in there. This Watchtower. Sorry, let's see. This is the one where both of these did some basic arithmetic. This one, Defense of Consolas, ended up doing some fancier stuff with the output, like changing the color and stuff. Repairing the Clocktower, we have some logic in there, if statements. Watchtower, this was much more sophisticated logic that we had to write. But again, if statements and ands and greater thans and less thans and greater than or equal to's kind of stuff. And we got 500 experience points, which puts us, we're now at level 4, and we are 1/8 of the way to level 5. So I think that about wraps it up here. We will pick this up again sometime soon. Thanks for joining me.